Assalamu alaikum warahmatullahi wabarakatuh. Students, in this video we are going to discuss about 15.3 transmission of pressure. Right? For this section of your chapter, 15 chapter, right? A diagram is given in your book. Look at your book in page number 68. It's given there in your book, right? A nice diagram. There are some liquids inside, a liquid inside, right? 10 centimeters squared, 10 centimeters squared is the cross area of this column or this arm, right? For this column, the cross area is 200 centimeters squared, right? A special and very important basic very fundamental theory, right, according to the physics, right, according to the pressure, for the pressure is the Pascal's principle, right? The Pascal said if you are getting an uncompressible and non-viscous, don't worry about the terms, right? Uncompressible, non-viscous liquid, if a force exerted inside the liquid, it is going to be distributed equally throughout the liquid. If you are giving a force inside the liquid, the pressure inside the liquid, the pressure which is given, it's not going to be changed. It will be distributed equally in all the places, right, of liquid. Right? If you, for an example, now you are getting a column, right? Inside the column, your head is here, the water level is here, right? First, initially, your head is going to feel, right, how much the pressure of this liquid column, right? Now, if you are giving, we'll take for an example 10 pascals that you are feeling here, right? In the previous videos, I didn't mention the unit of the pressure. I'll tell you now. The pressure is equal to the force divided by surface area. Therefore, the force is given in the unit of Newton and the surface area in meter squared. Therefore, Newton meter minus 2, right? This can be illustrated as Pascal, right? Like kilogram meter second minus 2 will be illustrated as Newton. You know that, right? The same as Newton meter minus 2 can be given in Pascal. Then the unit of the pressure is Newton meter minus 2 or the Pascal, right? In another way we can say, for the Newton we can give kilogram meter second minus 2, then that is divided by meter squared. Then the unit of the pressure can be given in the basic terms as this, meter minus 1, second minus 2. Okay, now move on to this example. Now I am giving 5 pascals to the liquid, the top of the liquid, right? Then before we give this pressure, the pressure exerted on the head is 10 pascal by the liquid column. If you are giving 5 pascal extra, then the total of 15 pascals is going to be felt here, right? Now, without removing this, I am keeping this, your head is coming at this point, right? Now, I am saying by this liquid column, less than the 10 pascals of pressure is going to be exerted on this head. I will tell that as 5 pascals. Now, what is the total pressure that has been exerted on this head? 5 and 5 is going to be 10 pascals, right? This idea is giving you, right, that by getting your head, right, in various places, according to the liquid column, the pressure varies but the given pressure is equal in this place and this place, right? That is what Pascal said. If we give the pressure in all the places, it will be felt equally, right? The extra, the more pressure, the extra pressure. According to the liquid column, the pressure is going to be vary, right? But the external for the pressure given is not going to be get vary, right? It's going to be equal in all the places, going to be felt equally in all the places, right? Which has been given from outside. Now, the same example is given here. If you are giving 20 Newton, right? If you give 20 Newton from outside, right? You are exerting a pressure, right? Exerting a pressure, P is equal to F over A, right? The value is going to be 20 divided by 10 is going to be 2 pascals, right? Therefore, this 2 pascals is going to be distributed in all the places, Then the pressure which is going to exert on this piston, we will say this as piston, right? On this piston is going to be due to this force, right? It's going to be 2 pascals because it's going to be felt in all the places as equal. 2 pascals are going to be felt, right? Therefore, how much of force is going to be exerted here is 2 pascals. The pressure is equal to force over surface area, right? The pressure exerted externally got is 2 pascals is equal to force divided by 200. Therefore, F is going to be equal to how much? 400 pascals. Sorry, 400 newtons. Then 400 newtons are going to be felt. By giving 20 Newton, right, you can give 400 Newton on this piston, right? Then you can hold an object which is 40 kilogram, right, on this piston, right, with what? A small amount of force. No? Think about this. A small amount of force you are exerting, right, that has been holding, that is holding 400 newtons or giving 400 newtons of force here. Then if you keep 40 kilogram of object or 400 newtons of object, that 400 newton is going to give a force downwards, 400 newton upwards, and this is going to be in the equilibrium. This can be held, right? If you increase 21, right, then the value is going to, the 400 is going to increase, right? With this increment, right, this can be lifted up, right? This is what happening in the hydraulic jacks, right? If you look at your page number 69, in the page number 69, the hydraulic jack is given there, the lifter is given there, right? To lift the vehicles, go through the knots and you can understand it. And the hydraulic jack is given there in the 70, page number 70, right? And the same phenomena, right? The hydraulic brakes, which is in the vehicles or the four-wheel vehicles, right, is going to be worked, right? Hydraulic brake system. By the brake pedal, you are giving a force. That force will be distributed as pressure equally, and the brake shoes, which is connected to that liquid, the liquid is going to feel a force and it's going to hold the tire to stop the tire, right? That is what happening in the hydraulic brakes, right? Then the same phenomena, the Pascal's principle, is used in the hydraulic brake as well, right? In all the places, right? We are using some liquid, some fluid, right? Which is non-compressible and non-viscous. Not non-compressible, very less compressible and very less viscous liquids. Okay. That's it for the 15.3. Inshallah, we'll see the 15.4 next video. Jazakumullah khair. Barakallah.